ダメだねダメよダメなのよあんたが好きで好きすぎてどれだけ強いお酒でも歪まない思い出が
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidil. The scope for this project is radiation, and our group chose two subtopics to be covered in this video. Here I will start with the first subtopic, which is about atmospheric and solar radiation. The Earth and atmosphere are warmed by the energy from the Sun. So, I will explain what happens to solar energy as it enters the atmosphere. There are three things work together to transfer energy to our atmosphere. One is radiations, second is convection, and lastly is conduction. But here I will focus only to the radiation. Radiation is the transfer of energy as electromagnetic wave. The Sun radiates a huge amount of energy, but the Earth only receives a tiny percent of the energy and enough to sustain all life on Earth. Now, as this energy from the Sun enters the atmosphere, from 100%, it will divide to 5, which is 25% is scattered and reflected by the cloud and air. 20% is absorbed by the ozone and reflected by clouds. 50% is absorbed by the Earth's surface, and 5% is reflected by the Earth's surface. Different type of electromagnetic wave carries different amount of energy. The shorter the wavelength, the more energy carried by the wave. I repeat again, the shorter the wavelength, the more energy carried by the wave. Solar radiation is referred to the energy emitted by the Sun. Most of solar radiation is the visible light we see with our eyes, but it also includes with wavelength which we cannot see. So next I will explain about atmospheric radiation. Atmospheric radiation is the flow of electromagnetic energy between the Sun and the Earth's surface as it is influenced by clouds, aerosols, and gases in the Earth's atmosphere. It includes both, which is solar radiation and long-wave radiation. Long-wave radiation means the lower energy. Several factors influence the amount of solar radiation reaching the Earth's surface and the amount of radiation leaving the Earth's atmosphere. These factors include atmospheric elements such as 1. Cloud droplets, 2. Humidity, 3. Temperature, 4. Atmospheric gases, 5. Aerosol particles, and even the characteristic of land and ocean surfaces. Atmospheric radiation is critically important to understand because it affects both weather and climate. We cannot see the long wave, but it can be felt, which known as heat. In summary, the type of radiation emitted by the Sun and the Earth are determined by their temperature. The Sun, which is very hot, emits high energy shortwave radiation, while Earth, which is much cooler, emits lower energy long-wave radiation. So, before I end my part, I want to share one fun fact about solar. It takes 8 minutes for the energy from the Sun to reach Earth. So next, my friend will continue this session.
Hello and Assalamualaikum. My name is Aiman Ikmal. Now that we know the basic of atmospheric and solar radiation, time to do some tutorial. Let's go. Okay, a manufacturing facility located at 40° north latitude has a glazing area of 40 meters square that consists of double pane windows made of clear glass SHGC, which is 0.766. To reduce the solar heat gain in summer, a reflective film that reduces the SHGC to 0.261 is considered. The heating season consists of June up to September and the cooling season October through April. The average daily solar heat fluxes incident on the west side at this latitude are 1.86, 2.68 and so on, as you can see in the question here, kilowatt hour per day meter square for January until December, 12 months respectively. Also, the unit cost of electricity and natural gases are $0.08 per kilowatt hour and 50 cents per term respectively. If the coefficient of performance of the cooling system is 2.5 and efficiency of the furnace is 0.8, determine the net annual cost saving due to installing reflective coating on the windows. Also determine the simple payback period if the installation cost of the reflective film is $20 per meter square. Now we have two things to find out here. Let's go. If you are wondering, this is what the situation looks like. Alright, first thing first, I've got a table here. Inside the table we have month from January to December, the days in those months, and the heat flux given from the question for each and every month. From the question, we are only focusing on the heating season and the cooling seasons. Let's find out the average heat flux for the summer, which is heating season. So we are going to times the flux with their days. $508 kilowatt hour per year. Now it's time to calculate the heat flux for winter. Okay, from the calculation we can get the heat flux for winter is 548 kilowatt hour per year. Okay, from there the decrease in annual cooling load and increase in annual heating load due to the reflective film become, we can calculate that, is heat flux for summer, area of glazing times SHGC without film minus SHGC with film. I'm gonna put F there. Okay. $10,602 kilowatt per year. Same goes to the heating load increase. Same formula. So okay, we are almost done. Next, we will calculate the implementation cost, which is installation cost of reflective film times the area of glazing. See, we can know this from the question, which is $20 per meter square times 40 meters square. The answer is $800. Okay, finally, from those information we get, we will know this gives a simple payback period of, let's calculate simple payback period is equals to the implementation cost, which is $800, divided by the annual cost saving, which is $92 per year. From this we can get the answer is 8.7 years.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib bin Muhtasam, and today I will be presenting about the theory of the view factor. Okay, the view factor is the radiation of heat transfer between surface depends on the orientation of the surface relative to each other, as well as their radiation properties and temperature. For example, a camper can make the most use of a campfire on a cool night by standing as close to the fire as possible and by blocking as much of the radiation coming from the fire by turning or facing to the fire instead of the side. Okay, to account for the effect of orientation on radiation heat transfer between two surfaces, we define a new parameter called the view factor, which is a purely geometric quantity and is independent of the surface properties of the temperature. It is also called the shape factor, configuration factor, and angle factor. The view factor based on the assumption that the surface diffuse emitter and diffuse reflector is called the diffuse view factor. The view factor based on the assumption that the surface are diffuse emitters but specular reflectors is called the specular view factor. We consider radiation exchange between diffuse surface only, and thus the term view factor for this simply means diffuse view factor. The view factor from a surface I to a surface J is denoted by Fi to Fj, or we can call it Fij. There are a few formula that we can define of the Fij based on the condition. The first condition is the parallel plates with midline connected by perpendicular line. Second one is the inclined plate of equal width and with a common edge. And the third one is a perpendicular plate with a common edge. The fourth is a three-sided enclosure. And the last one is infinite plane and row of cylinder.
Assalamualaikum. My name is Muhammad Hadi Hakimi bin Syamuddin.
Okay, I will be present about my part that is the view factor, how to find view factor. Okay, for this question, I will read first. The cylindrical heater are spaced equally at 5 cm apart in a row, and the heater are positioned between two large parallel plates. If the diameter of the cylinder is 35 mm, determine the view factor of the plate at the row of cylinder F12 and F32. Okay, from this question, we can assume that we just list down first. The L is equal to 5 times 10 -2 meter. We just convert centimeter to meter. And for the diameter, we can convert it to 35 times 10 -3 meter also. Okay, after that we see that the question has stated that equals, that is F12 equal to F32. So the length here and here is the same. Okay, for next, for determine the view factor, we can use the formula of infinite planes and row of cylinder. Okay, from this formula that state F is equal to 1 bracket 1 minus bracket 1 minus d over s power by 2 1 over 2 plus brackets d over s tan -1 s square minus d square divided by d square power of 1 over 2, and that's the formula is this. Okay, so to solve it, we just put this into this. Okay. For we know the D is the diameter, for the diameter, and S is for the length, and then we can just put it in this formula. F1 minus bracket 1 minus D is 35 times 10 negative 3 over S 5 times 10 negative 2 power by 2. Okay, betul bracket 1 over 2 plus D is 35 times 10 negative 3 5 times 10 negative 2 5 and then we close the bracket, done. Negative 1 S is 5 times 10 negative 2 minus D is 35 times 10 power of negative 3 divided by 35 times 10 negative 3, and then the power here is 1 over 2, and then we can solve it. We can solve this and then we get equals to 1 brackets 1 minus 0.49 power by 1 over 2 plus 0.7 times 45.57 degree. Okay, and then we get 0.2859 plus by 31.899 degree. We cannot plus these two number because this is in degree, so we have to change it into radian per second. So 859 plus by 31.89 times pi over 180, and then we get it in radian, so we get 0.2859 plus 100.214 over 180, and then we get the final answer is 0.828426. So is F32. That's it. We got the answer here. Okay, that's all from me. Thank you for listening.